Ladies and gentlemen, I want to welcome you here to the EuCNC panel that is hosted by Cornect, a CSA action item funded by the European Commission, which is focusing on paving the way for European technological sovereignty in 5G and beyond. My name is Gerhard Fettweis. I'm Vodafone Chair Professor at TU Dresden, and I'm heading the Barkhausen Research Institute, which is working on the trustworthiness of the tactile Internet of Things. So the challenge for Europe is to see what is our stance, our position, to make sure that we can thrive and drive wireless technology such that we can make this happen because we have enough sovereignty from the electronics point of view. However, if we look at the situation here, Europe's percentage in the world in electronics and semiconductors is very, very small. And it's actually reduced every year. So that's why the question is, what can we do? What can we identify to make sure that we make Europe's position stronger again? Cornect is about European core technologies for future connectivity systems and components. So it's been running for approximately 1 year and has still 1 year to go. TU Dresden is the coordinator and me in person as the coordinating person. We have 12 partners from 7 countries and we have about 100 experts involved with their expertise in all the different areas that are needed to make this kind of a strategy happen. Cornect partners cover the whole value chain, from verticals to connectivity platforms, subsystem components, all the way to devices. So we have 12 partners, but we really cover the value chain nicely. And we cover telecommunications, microelectronics, 5G and beyond, and verticals, SME community. We have associations, academics, research technology organizations. We have every different component and facet that you can think of covered with this actually not that big set of 12 partners. So our objectives are to decrease European dependence on other continents supplying us with components and electronics to ensure that we can stay ahead and advance nicely in the wireless market of today and of the future. We want to do this by bringing major players in microelectronics and telecoms together. Obviously, that is the one part. We also establish, of course, then connected to those industries, the smart systems, smart networks and services community, and the key digital technologies community to come up with the right innovation agenda of what is needed as we go ahead, and also an analysis, of course, of where are we good, where are we strong, and where are we weak, and where are possible new opportunities popping up where there is no position of Europe yet, because this is something very new that is only going to happen maybe like within 6G. And then finally, of course, we want to promote our results to the stakeholders in both the public and private sectors so that we can really champion this in the community. We do this with basically coming up by dividing our work into 3 different areas that are covered by expert groups. One is on compute and storage, one is on connect and communicate, and one is on sense and power. We have 100 experts from internal and external, also from outside of the Cornect partners, that are working on building basically the roadmap, building the understanding of what is going to be needed, where are we strong at, where are we weak, to make this kind of a SWOT chart analysis, and then take this from vision to investigate in the technical domains to roadmap this and then finally come up with the right guideline and recommendation of what needs to be done on the European level. Obviously, the CoreNect experts are involved not necessarily with their company position only, but with their true technical expertise. So that's why this is a collective view of all these experts, and that does not mean the companies involved fully embrace this view. Thank you very much for all the partners and all the individuals of CoreNect. Here are the pictures of the key contributors of the 12 partners that are really actively putting a lot of time and effort into this to make this happen. Thank you so much, because without you, we could not build this strategy for Europe. And now I come to the panel. So within EuCNC now, we have the chance to take this topic to our panel, where we have 4 top panelists from in and outside of CoreNect, and where we want to touch this and gain new insight and new views on really what needs to be made happening, such that we can make sure Europe is going to thrive and be great for the wireless world of today and of the future. With this, let's start with the panel. Dear participants of EuCNC and our CoreNect panel, it is my pleasure to now introduce our first panelist, Caroline Pedron. She has been active in the electronics and semiconductor industries for most of her career, primarily at Philips and NXP. She also has experience in the telecommunications and 5G industry, both at European and global level. After graduating as an engineer in electronics, she was involved in RD&I activities, then further moved into collaborative projects and partnership management. She has held different managerial positions in France and Belgium, enlarging her responsibilities to public relations and external affairs. In her current position as a Director General of AENEAS Industrial Association, she supports the European electronic components and systems industry in dealing with the European Commission and national public authorities. AENEAS has a special focus on strategic investment and research and innovation funding programs at a time when European leadership is being challenged in a global environment. In particular, AENEAS plays an active role as part of the private members board of the Excel joint undertaking under Horizon 2020. In addition, AENEAS is active in the operation of Eureka funding instruments through managing the Penta Cluster program, where Penta was created to catalyze collaborative RD&I in micro and nanoelectronics-enabled systems and applications, which is working in close partnership with national funding authorities. And now the floor is yours, Caroline. We're very open and we're looking forward to hearing your statement.
Good morning. I am very honored to be invited to share views in this panel of components and hardware on the road to 6G. Let me first introduce AENEAS, as the telecom community might not be very familiar with it. AENEAS is an industry association gathering more than 400 members of the electronics component and systems community, all along the value chain, from semiconductors up to the application level. It aims at creating an effective funding landscape and promoting networking and collaborative RD&I work. It also shapes the R&D&I landscape by preparing, in a joint effort with 2 other associations, Artemisia and EPOS, the Strategic Research and Innovation Agenda, which serves as the basis for several RD&I collaborative programs in the framework of the Eureka clusters, as well as in Horizon Europe. The Strategic Research and Innovation Agenda will be the basis for the new partnership on key digital technologies, KDT, in Horizon Europe Cluster 4, Digital Industry and Space, together with several other partnerships, including SNS, Smart Network and Services. Why is ENEAS working with the telecom industry community in Connect CSA? As you know, beyond 5G and 6G enable new disruptive applications with benefits for the society, with 6G providing high quality of service, high bandwidth, and quasi-zero latency. As you can see in this picture, microelectronic components are key elements of the telecommunication value chain. Hence, the strategic importance of secured and trusted sourcing for the telecom industry. The target of Connect CSA is to create a bridge between the microelectronics actors and the telecommunication actors to jointly develop a high-level strategic roadmap of core technologies for future connectivity systems and components, targeting the new next generation telecommunications networks and services. The aim is to define a strategy for the years to come by comparing roadmaps, identifying strengths and gaps, challenges and opportunities. In this slide, you see the strengths of the European ecosystem as identified by Connect. The first one is industry. In industry, we have semiconductor manufacturing equipment suppliers like ASML. We have advanced substrates like SOI, prepared by Soitec. We have differentiated semiconductor technologies addressing specific needs of telecommunications, be it for radio frequency, millimeter wave front-end modules, high power, or photonics. And those technologies are, for instance, advanced by CMOS, RF SOI, gallium nitride, fully depleted SOI, gallium arsenide, and indium phosphide. And always in industry, we have leading telecommunication infrastructure providers, hence the importance of joining forces together. Then we have a major asset with research and technology organizations in transforming knowledge into industrial success stories. Now, what are the challenges and opportunities for Europe beyond 5G and 6G? Over the next 10 years, 5G and then 6G are expected to connect billions of devices, to digitize industries, and bring social and economic advances in many vertical sectors. Developing the necessary core technologies, it is crucial for Europe to decrease its dependence on non-European technologies. However, if you look at the microelectronics and semiconductor business, it is a global business in which no regions of the world, including the US, masters the complete value chain. The structure of the supply chain is fully global, based on geographic specialization, which leads to economies of scale and delivers enormous value for the industry, as well as lower prices for the end user or the citizen. Therefore, mastering the value chain for all component types in Europe is not feasible in the short or medium term and probably not desirable. Having said that, Connect has made a specific exercise to identify gaps and opportunities for Europe, focusing on 4 key applications described in Connect deliverable. The first one on local connectivity shows that there is a clear European leadership on technologies like low power wide area, Bluetooth, Wi-Fi, Ethernet, and microcontrollers used in industrial applications like industrial IoT, healthcare, automotive. In radio access networks, there are opportunities to leverage derivative technologies to increase market share. In microelectronics for cloud-centric applications, there is opportunity to develop a European fabless ecosystem on advanced SOC design and investigate new approaches towards AI engines. And in consumer and wide area connectivity, there is opportunity to strengthen positions in the front-end modules. As I just explained, mastering the value chains for all component types in Europe is not a valid target, but we must focus attention on the missing elements, the so-called choke points, along the value chain to mitigate the risks. As a conclusion, let me share a few recommendations to mitigate European weaknesses. First, we must maintain the current investment effort on derivative technologies like power, sensor, analog, photonics, and complement the portfolio with RF filters, advanced packaging technologies. We must invest in enabling AI technologies, both at the edge and in the cloud. We must leverage the presence of the leading European telecommunication equipment infrastructure suppliers by cooperation and co-design. We must develop IP industry in Europe as a first step towards creating a regional market, which will ensure availability of trusted electronics and might later justify investments in advanced CMOS manufacturing capabilities. We know that public funding is essential and brings high return on investment. And for increased synergies, we must encourage cross-partnership calls like joint calls in the future, KDT and SNS partnerships. The European Commission and public authorities play a pivotal role to ensure and secure access to foreign technology providers through trade and foreign policy measures. Enforcing trade rules, avoiding the creation of new trade barriers, safeguarding strategic European assets, in particular, European companies representing a choke point for other regions. And then counting on the support of industry associations like INEAS and the 5G Infrastructure Association to stimulate and facilitate full engagement of industry. Thank you for your attention.
It is now my pleasure to introduce our second panelist, Björn Ekelund. I've gotten to know Björn Ekelund over multiple projects where we collaborate, and I really cherish his expertise. Björn received his Master of Science and PhD in Telecommunications Microelectronics from Lund University in 1985 and 1987, respectively. He joined Ericsson in 1987 and was over almost 2 decades responsible for microelectronics and software development for Ericsson's mobile phone products. In 2004, he moved into product planning and marketing and later into strategy, working for the ST Ericsson joint venture. Since 2015, he is with Ericsson Research, leading electronics, antenna, and IoT research within the research organization. Björn Ekelund serves on the board of several publicly funded research and innovation programs, as well as on that of some corporations and government bodies. He is a well-established expert that is cherished by many people. So we are very interested in hearing your statement now, Björn, considering what we want to touch here within our panel. The floor is yours.
Good morning, everybody. Great to be here. I'm Björn Ekelund with Ericsson. There's a world championship going on, and the participants don't compete just in industrial production and export. It's also about efficient logistics, sustainable transportation, fossil-free sustainable energy, cost-efficient and accessible healthcare, even efficient government. Without having access and exposure to modern wireless infrastructure, Europe will simply fall behind in all these areas. This means that 5G and related technologies is not a priority for the telecommunication sector, it's a priority for the entire society. State-of-the-art wireless infrastructure is a key element in societal development. This has triggered many governments to make it a top priority to roll it out. The most telling example may be China, where over 700,000 base stations were installed by the end of last year. Korea is another one, with 98% population coverage at the same time. Europe is nowhere close. With all products and services becoming connected, microelectronics show up everywhere. Microelectronics form the hearts and brains of all connected and smart products. This has made them a matter of geopolitical importance, and the current supply chain challenges have really galvanized the situation. Some governments have acted quite forcefully. Europe needs to do this too, but supporting existing players is not enough. We need to build a new ecosystem. So let's look at where Europe is in this global race. Europe has strong semiconductor companies, but they are few and not very large. Also, due to lack of scale, all European semiconductor players have fallen out of the Moore's law race and turned their focus onto more differentiated technologies. Counted per GDP, Europe has only half of the global average of sales revenues in electronic components, whereas we're quite close when it comes to end-user equipment and machinery, such as cars, airplanes, and refrigerators. The strategic challenge for Europe's industries is that when products are becoming connected and smart, there is a flow of value from the end product to the very complex components. In industries where the components and subsystems traditionally have been mechanical, like the car industry, this is particularly noticeable. In their respective segment, Europe's semiconductor manufacturers are strong, but they do not manufacture any of the large-scale system chips that drive, for instance, autonomous vehicles or 5G smartphones. This means that the big names designing and manufacturing the hearts and brains of many European flagship products are not European. Many of these manufacturers also enjoy significant support from their respective governments. If we move into design tools, which is really at the center of the microelectronics value creation process, the situation is even more extreme. 90% of all sales are made by US companies, and they continue to strengthen their position. There's a lot of discussion about semiconductor manufacturing in Europe, and of course it's very important from a supply chain security perspective, but it's really important to understand that the majority of the value is created further up in the value chain. If the manufacturing of a naked silicon chip of a certain size costs €1, a standard component with the same size chip, packaged and ready to use, can be €5, and a complex system chip, again of the same size, can be €30. This upside-down value pyramid also explains why only a few companies can afford to play at the bottom. Massive investments on enormous scale is required to build a sustainable business. Higher up in the pyramid, investments are much more modest and the rewards are still high. This means that for Europe, from a value creation and competitiveness perspective, the strategic priority is the design and sales of complex chips rather than the actual manufacturing. So how do now strategically conscious industry players react when the product value moves into small pieces of silicon and you want to stay ahead of your competition? The only sensible thing is to design your own. To stay competitive, European industrial players need to take this challenge seriously and not let their product differentiation, value add and competitive edge run between their fingers. So in summary, 5G is an innovation platform, and to do world-leading innovation, we need to have access to this platform in Europe. We need to strengthen our SoC, system-on-chip design capabilities. This is a key value creator in all connected and smart products. We need to accelerate digitalization. This is not just about competitiveness, it's also sustainability. We need to drive academic excellence. This is where talent and innovation starts. And finally, we need to accept the fact that the majority of the world's brightest people are not born in Europe. Thank you.
It is now my pleasure to introduce our third panelist, Lars Reger. He is an Executive Vice President and Chief Technology Officer of NXP Semiconductors. As CTO, Lars is responsible for managing new business activities and R&D in the focus markets of automotive, Industry 4.0, Internet of Things, mobile, and connectivity and infrastructure. Before joining NXP, Lars gained deep insight into the microelectronics industry with a focus on the automotive sector. He began his career with Siemens Semiconductors as product engineer in 1997. His past roles at Infineon included head of the process and product engineering departments, project manager for mobile systems chip, and director of IP management. Prior to joining NXP as head of automotive strategy in 2008, he was responsible for business development and product management within the connectivity business unit at Continental. In December 2018, Lars was appointed CTO, his current role, and has since then been responsible for the overall technology portfolio of NXP. Since April 2019, he has been a board member of the Committee of Digital Economy, Telecommunications and Media in the German Industry Association. Lars is also on the board of directors of ITS World Congress and a member of the Forbes Technology Council. Lars earned a degree in physics from Rheinisch Friedrich Wilhelms University in Bonn and an MBA from the London Business School. Lars, our careers have touched multiple times, and I really cherish your opinion, and that's why I'm very excited to have you here and am really looking forward to hearing your position. Thank you for joining the panel.
Hello, ladies and gentlemen. Big thanks for having me here at the 2021 EuCNC and the 6G Summit. My name is Lars Reger. I'm the CTO of NXP Semiconductors, and NXP Semiconductors is one of the big European semiconductor players. And we are specifically focused on bringing smart connected devices to the market, which is a very attractive position today because the analyst prediction is that there will be around 50 billion of those smart connected devices by the mid of this decade, 100 billion of those smart connected devices towards the end of this decade. And these smart connected devices are, for example, rolling robots, cars, are manufacturing robots in industry, are devices in your smart home or portable devices that you carry at your body. So in other words, all these devices that try to sense their environment, compute a smart advice, connect to the cloud or other of those devices, and then actuate based on the information and the computing that they do. Now, for all of those, there is of course a never-ending need and hunger for seamless connectivity, for energy efficient connectivity, and for purpose optimized connectivity. And what you're seeing there is basically, of course, as business trends, as drivers behind that, an enormous amount of societal goals and ideas to have these devices more autonomous and transferring the world around us into a world, as we call it, that anticipates and automates. So you want to have devices that you can trust, devices that can forecast what you want to do as an end user, what you want to do next, and then adjust themselves or their peers to what you might want to do. I give you the example of a smart thermostat. The thermostat wants to know where you are, how many family members are at home, how the weather forecast is, and then wants to adjust the house climatization exactly to what's happening next, who's coming home, by when, and how the weather will be. So you need to sense, think, connect, and then act with your climate control of the house. Ideally, this of course only works when you have complete cellular coverage or wireless coverage, so to say, when you are very human machine centric, and when you also can merge the sensory experience and the connectivity experience. So in other words, ideally you would have a technology that can sense where the different objects are or human beings are, so is aware of the analog world around itself, plus is able to communicate. Well, and there, of course, the attractivity comes. 5G is a pure communication technology. 6G has potential reach also in this sensor area. Now, from today's situation, we all know that 5G for us Europeans has a couple of drawbacks. The innovations are largely non-European based. You have a couple of big European infrastructure players still, but a lot of the innovation at its core of 5G are Asia or US driven. And of course, this is what we would like to change, not only from a revenue or market reach perspective, but also from a point of security. You all know these big debates that we have around infrastructure security, who's building which type of backdoors into the solutions and so on. Now, therefore, of course, my plea is to take a leading position already now for Europe to buy an entry ticket into the 6G development and lead rather the ecosystem than to follow. And why should and could we do that? So what would be the reason why we can be successful there? Well, very simply, 6G is in the range of 100 gigahertz communication. Europe has quite some experience in transmitting and receiving in this frequency band, because we are working as market leaders already in the automotive radar segments, for example. They are communicating in the range of 80 gigahertz. We have a lot of that millimeter wave experience. We have a lot of the microcontroller experience. We have a lot of the 5G infrastructure experience also inside NXP. And therefore, I think we would be pretty well suited here in Europe to take the next steps in helping develop, shaping the 6G appearance and how this industry could look like and what the technology could do for us. Now, what I said is, normally when we talk 3, 4, 5G, we only think of a communication technology. But I mentioned already, 80 gigahertz technology is a pretty good sensing technology as a radar technology to detect blocks of steel, moving objects, but also big bags of water. And I'm nothing else but an 80 kilo bag of water with a couple of bones inside. So human objects, living objects can be very well detected also by these 80 gigahertz radar systems, even in high resolution. Just think of the situation where you could combine the communication path in 100 gigahertz and the sensing path. So for example, building an infrastructure radar at your traffic light, sensing whether there is pedestrians on the walkway, and you can communicate directly to other traffic lights, to traffic infrastructure, or to moving objects like cars. So there you would have, of course, very, very advanced, very, very smart and smooth surveillance systems also for critical infrastructure. You could drive down with highly efficient silicon here, the energy consumption. You can make it way more purpose-driven, optimize your radios, all of what we are very much used to with our technologies. So in other words, Europe has a lot of technical ingredients to really go in, lead that market and help shape this and take our share in 6G innovation. Now, of course, that never would work as a standalone pitch by, for example, a company like NXP or any other player in that market. Of course, what we need is an early engagement between the MNOs, between the equipment vendors, and between the component suppliers and software block suppliers, like, for example, an NXP. We have all of that in Europe. Of course, ideally, we would have a couple of political support stimuli also there, subsidy programs, research programs, bringing in research organizations, out of which we have a very, very solid base in Europe. And with that, I'm very convinced that we have a chance, if we just get our act together, to really lead here, to do the core innovation, to out-innovate other regions, and to really help shape the era of the smart connected devices for a world that anticipate and automate. Thank you.
And now let me come to our fourth panelist, Professor Thomas Kropf. Thomas is president of the Bosch Group's corporate sector for research and advanced engineering. Headquartered in Renningen, Germany, the research sector has locations across the globe, including major research and technology centers in North America, China, and India. It covers all the systems and technologies found in the Bosch products, ranging from mobility solution, industrial technology, energy and building technologies to consumer goods. In addition, Thomas is also responsible for the Bosch Center for Artificial Intelligence, as well as for GROW, a Bosch internal startup platform. Prior to his current assignment, Thomas Kropf was Senior Vice President with responsibility for cross-divisional automotive systems engineering in the mobility solutions business sector. In this role, he also defined the company's automotive strategy, reporting directly to the Bosch Board of Management. Further assignments included responsibility for the infotainment business unit of the Bosch Car Multimedia Division, product management and advanced engineering in the Chassis Systems Control Division in Abstadt, Germany, software and systems engineering, as well as customer project management for radar, video, and ultrasonic driver assistance systems in the driver assistance business unit in Leonberg, and microelectronics development in the automotive electronics division. Professor Thomas Kropf joined Bosch in 1999 after a spell as an assistant professor at the Karlsruhe Institute of Technology, Germany. He holds a master's degree in electrical engineering from the University of Darmstadt, Germany, as well as a PhD in higher doctorate habilitation in computer science from Karlsruhe Institute of Technology. In addition to his position at Bosch, Thomas is adjunct professor at the University of Tübingen, Germany, where he teaches computer science. Well, Thomas, the two of us started not our career, but also had some very joint research in the 90s here in Dresden. So our careers go way back, and it's always fun to see you advance so nicely. And now in your new position, I think you're very well poised to give us your view on what we need to know about here in this panel on CoreNet. So we're very excited to have you here and are open to listen to your position. Thank you, Thomas, for joining.
Hello, everybody. My name is Thomas Kropf, and I'm president of Bosch Corporate Research and Advanced Engineering. In my brief introduction, I will give the Bosch perspective on future 6G ecosystems, the business sectors, the relevant technology trends, the interplay between major stakeholders, and the opportunities, but also the prerequisites to make it an European success. Bosch is not only the world's largest automotive supplier, but also a leading IoT company. In all our product areas, we are actively driving connected and automated applications, many already containing AI. We are active in industrial technology, mobility, energy and building technology, as well as consumer goods. Hence, in all those domains, our products are already connected or will be soon. Obviously, connectivity technologies, especially 5G and 6G, play a major role as a key enabler. Megatrends like autonomous driving, connected mobility, electrification will lead to significant changes in the existing ecosystems. Those trends are fueled by a massive and fast advancement of technologies like artificial intelligence and big data analytics, parallel and edge computing, power electronics and battery technology for electrification, and naturally, 5G, 6G connectivity plays a decisive role. In the automotive domain, these technologies have a huge impact on the vehicle's electronics and software, transforming the vehicle into an ultimate electronic device. Many car functions will be realized outside of the car in a much more flexible and adaptable way. In industrial applications, we see significant progress towards the factory of the future. highly automated and connected, manufacturing flexibility will become reality, which is just impossible today. The rapid pace of innovation around intelligent systems in cars and industrial applications is disrupting existing business models and ecosystems. New partners emerge. New collaboration models are needed, which in turn needs a stable legal framework. To give you an example, if functions for a car are realized by connected edge computing, we do need more players involved than just a car manufacturer and his tier 1 suppliers. I will explain this on the next slide. The left picture shows the traditional approach. A car manufacturer decides about a certain functionality and the necessary components, like an automated emergency brake. Components may be a radar, a video system, or both. This is then sourced from a tier 1 supplier. The supplier again gets its components, like a microprocessor, from a semiconductor supplier. However, this does not take into account connectivity. Assume that we have a connected emergency brake, which is based on information from other vehicles. Now it's getting more complicated. Now we need the car manufacturer, the tier 1 providing sensors and connectivity units, semiconductor companies which in addition provide now communication chips for like 5G, but in addition we now need also communication infrastructure and telecom providers. If we store map information in the cloud, we need an IT company providing a reliable, real-time capable cloud. Or we use edge computing capabilities, like in a communication tower. There, perhaps we do have the cloud storage too, if we use an edge cloud for efficiency and real-time reasons. All players have to seamlessly work together. And we need different business models, as all of them want to earn a bit of money. And in terms of EU sovereignty, we want to provide European vehicle safety and have to act accordingly. What I've shown to you may look complicated. And to be honest, to some degree it is. On the other hand, there are great opportunities, especially for Europe. The new 6G applications need strong domain expertise, and European countries have plenty of it. Connectivity and data-driven AI applications raise serious questions concerning data security and privacy. Digital trust is a prerequisite for a broad customer acceptance. And in this regard, the EU is best prepared with its GDPR legal framework and data initiatives like Gaia-X. This gives us a head start. However, we need facilitating frame conditions to keep the ball rolling at high speed. To foster these high-tech business opportunities, we need an innovative regulatory framework. One example is the provisioning of local spectrum licenses. Fortunately, some countries like Germany, France and the UK are well on the way. To jumpstart these high-risk, high-reward R&D activities, especially in the necessary cross-industry setting, we need significant funding incentives. And we should not underestimate how much tailwind we can generate by investments in network infrastructure. A connected road infrastructure for automated driving is a prime example. This does not only speed up industrialization, but also generates significant benefits for our citizens. These are really exciting times. I'm now looking forward to an inspiring panel discussion. Thank you.
Thank you, everyone, for these great introductory visions, as well as putting us, sort of setting the stage to give us an idea of really what is necessary to be done. So I can see that we have Caroline give us an idea that we really have to invest and make sure that we have a public funding strategy to make things that are happening. I can see that Lars gave us some intro or some insight in what will sensing and communication be and how that will change our environment and the opportunities that will be there also from a semiconductor side, and putting this into the European context of our position of being maybe strong or not so strong. We will hear about that. And I saw that Björn, for example, was talking about smart products need smart semiconductors. So if products are becoming smarter, do we need more smartness in our semiconductors, and who actually controls that part? And does Europe still have a stance in there? And Thomas, yes, you talked about also seeing that trust is something that will be a big point. And if we develop these kind of solutions and bring them to every corner in our home, will that not necessarily also be sort of questioned if we don't have an answer to the trustworthiness? Of course, you touched many other topics, but let me sort of, to set the stage, give some first kind of input on that side. Now let's have a look. So if we look at this from let's get started with what semiconductors will be, that we will have smarter products, that we have to trust, that we have to joint sense and communicate. Where does everyone, if I sort of see this as a joint kind of umbrella that all of you have given, what is sort of then, in terms of this European stance, and what do you think are action items that we have? Because I mean, let's put it this way. It's going to change. It's going to revolutionize everything, right? Sports, gardening, gaming, health, mobility, every corner of our life. So where do you think that if this is sort of our path towards 5G beyond and 6G, where does Europe have a stance, and where do we need to take action ASAP to make sure that we don't lose out? So whoever wants to go first. Thomas, you have the microphone on. Yeah, I ask you first.
Let me chime in with the first statement. I think we should act fast. So you know, Europe is known for talking a lot and acting slower than others, and this is now the opportunity to act fast and together. And I liked your introduction with the Connext, because we really have to bring together, and this is also something I wanted to bring over in my talk, the different verticals. So we need the telecom providers, the semiconductor manufacturers, but also the companies like Bosch are doing the applications. And we should really focus on some key applications where we are strong in Europe, like automotive, like industrial, and really go through the whole vertical as a team, so to say, and, defining the standards, defining the requirements out of the applications, because usually if you just do the bottom-up kind of thing and say we can do everything, just let's do it, it leads to nothing. We need concrete applications, and we need some stimulus. And there also, I think we should look at countries like China. They stimulate industries with investment programs. So not direct subsidies, but like road infrastructure. We had that in the talks a couple of times. Connected cars with respective infrastructure to create a certain, let's say, amount of demand, which then fuels the whole economy. And this I think is one important way to go.
Gerhard, maybe I can add to
Yes.
directly and jump right in the middle of it. I mean, we had heard in the beginning that there is quite some discussion that Europe is so far behind because we don't have 5 nanometer chips, and you know, point one, we are developing 5 nanometer chips for automotive even at the moment. So we are the first worldwide who go for automotive quality in these technologies. So it's not that Europe is behind on purely digital microcontroller activities. But what we need here for these 50 billion smart connected devices is a bit of a different recipe. It is not about highest performance compute. Look at your smart thermostat or your smart speaker, but it is about efficient compute, because these devices don't want to use current like a welding machine, but they have to live on a coin cell battery for quite a while. So what we need there is largely, and this is the European lead markets, automotive, industrial, smart home. What we need is efficient compute, plus we need to make the transition from the analog world into the digital world and back out again. So this sensing and connectivity part is a key ingredient, plus efficient compute. Now the fun is, this efficient compute is semiconductor-wise largely happening in technologies between 16 and 40 nanometers from a processing point of view, and for the sensors and actuators even in technologies between 40 and 140 nanometers. So what every technology developer would look at saying transistor dimension-wise pretty unexciting, but as you have to manage analog electronics, quite a challenge. So just to get this into perspective, the other thing is, of course, a lot of people can work with AI and machine learning, with nice detection systems, but it's very, very hard to combine this with functional safety and crypto security, so that you really can trust your device in the end. And these combinations of RF communication electronics, having the right AI and machine learning, which we, by the way, have on our machines, not NXP only, but the European players, having the right combination of being able to trust your device, so having the AI and machine learning that you're doing with functional safety and security and processing efficiently. These are the secret ingredients, so to say, and this is coming all out of our lead markets. Functional safety, I mean, we do that ad nauseum from the automotive industry. Your brake systems never fail, and so on, ISO 26262. Now, on the other side, we have the European lead market also with Infineon, NXP, crypto security, with ST, of course, not to be forgotten, with Giesecke and Devrient, Overture, Gemalto. I mean, there is a lot of players, with Bosch to be named, who are really in this ecosystem and can move the needle. As I said, if we get our act together and if we don't talk and wait too long. Funding-wise, there is only one thing that I would like to have, and that is a fast funding track. We have these IPCEI, big tankers, and they take quite a sizable amount of time to get the approvals, get the ideas written up, and so on. What I'm at the moment searching is, so Björn's company, my company, we are teaming up for getting the first 6G demonstrators early into place. Now, do we have funding quickly available for that to anchor it? No, we don't. And we are waiting and applying a lot, while other regions are also applying and say, hey, Lars, come to America. Lars, come to Asia for the first R&D center on 6G. And these anchor investments are comparatively small, but need to come comparatively fast. Just to throw the anchor already into the water and say, okay, here we stay, here we start, here's our nucleus. And the rest of the story is shaping up. But that is honestly the dynamics that I see and where we need to move. While the big tanker investments, they have more time. Yeah.
Okay, so Björn, you want to add something? And then I would like to ask Caroline.
Yeah, I think I agree with most of the things that have been said up until now, and I think there's another factor that where Europe can do better, and that is really the software ecosystem, because I mean we have a lot of assets in microelectronics, and I think we can build on that. But a lot of the value in modern systems is generated by the data, and it's generated by the software. And there we really have a weak position. I mean, there are a number of big players who own very powerful ecosystems and can leverage them when we move into the the new 6G domain and protect their position very efficiently. So I think the software, and that's sort of in a wide sense, everything from operating systems in devices to cloud frameworks. I mean, that's an area where I think Europe needs to play a bit more seriously.
And Caroline, what do you think in terms of fast funding? I mean, you sort of have a nice overview of the semiconductor industry. And so what do you think, how can we get such a fast track funding focused on certain topics up and going?
Yeah, first I would say that we have a very strong ecosystem and we are used in Europe to working together between the big companies, the small and medium-sized company, the startups and the research and technology organizations. I would say this is one of our strong assets and should continue. And you also see that in the collaborative programs like Excel in the past, KDT in the future, and all those cooperative programs where industry meets RTO to increase the speed of development and the way innovation goes to the market. So I think this is something that we are cherishing in Europe and will increase in the future if you look at the next KDT program where there is a factor, it's multiplied in terms of size from compared to Excel. So I would say the actors, the stakeholders, they know each other very well. They are used to work together. They can increase speed in being involved even more in those programs and take advantage of them. Having a closer relation between communities, like between SNS and KDT, as it is already started with Cornec, I think is also a must, and that is helping in that direction. About the technologies, of course, we have very strong basis with differentiating technologies. Maybe not in the advanced CMOS as was said, but in, I would say, specific technologies along heterogeneous integration that was also presented in the workshop 2 days ago. I think these are very strong assets on which Europe can continue working and differentiate itself from other regions of the world. So we shouldn't forget our assets and capitalize on them.
Okay, so if we then take this one step further, we say we're strong. We have automotive industry and smart home. Now, obviously what we can see is there is a challenge, because if I look, when I flew to Japan in the early 90s and talked to people, everybody had a washing machine that did automatic wash dispensing, did automatic sensing, used the water that was necessary, etc., etc., etc. Yes, this was sold like a decade later as a piece of innovation in Europe, and even modern washing machines today in Europe often enough don't have what the washing machines of the 90s had already in the Far East. So what I'm trying to point to, what you're saying, Caroline, what you're saying, Lars, what you're saying, Thomas, at least the three of you are saying, is we're strong in certain markets. I have the feeling we have not learned from the Tesla shock. Yes, strong in automotive does not mean you're ready to be rocked off your foundation, because the Tesla shock is not about electrification. It's about computerizing the car around one computer. So if you look at the newest electric car of Volkswagen, was delayed by a whole year because they didn't design it around a computer, but they had 17 computers and didn't get the software to coordinate correctly. So that's why we still haven't learned from that. And we have other industries that are going to be under attack. Bosch, Siemens, Hausgeräte, Miele, you name it, you got it. So everything that is in white goods. We're going to see sports. We're great in sports. We're great in entertainment. We're great in all kinds of different, if you look at supplies, garden supplies, from Husqvarna to whatever else. Europe is great. But every one of these industries, consumer industries, is going to be robotized and is going to be rocked by 6G. And how can we make sure that we don't stick and glue to automotive and all these comfortable markets, which are not so much, a little bit consumer market, but low numbers? And how can we break open to make sure that we know that we can create this value chain such that true European industries come and innovate? Because it's not a semiconductor problem, it is driving the whole value chain. So Lars,
Gerhard, spot on.
you want to answer.
You hit a couple of topics, of course, straight on the head. I mean, if we use a claim like we are strong in market A or market B as a reason to be complacent, then not even God can help us, right? I mean, so what you have described is very often we people have the tendency to rest on their laurels and say, yeah, we have the birthright for building cars because some 150 years ago someone put a combustion engine into a horse carriage. And now from that birthright we derive that we stay ahead of the globe, which is of course complete nonsense. I mean, as you put it, the world gets robotized. It's also not a software play only or a semiconductor play and so on. Nevertheless, 98%, to stay in that car example, 98% of all innovation at the moment is electronics and attached software in these horse carriages with combustion engine. Yeah. So from that angle, of course, we need to stay fast, nimble, and hungry, and you would call it competitive. Now, eager to learn. If we have the vision, if we have the technical leadership, and I think we have good people who can provide that technical leadership, then we have a chance to point our way into the future. Now, if these people in a slow and bureaucratic system have to fight with other regions that have maybe a more technical dictatorship approach, it gets difficult. And I'm not saying that I'm a fan of dictatorships at all, but what these systems have, if you have the right decider on the top, you are damn fast. The systems, dictatorship systems, as always, are always a victim to if you have the wrong one and you make a mistake, then you drive the entire thing into the abyss. But if you decide in the right way, you are fast. Now, what we should do is we should have a certain fast track to pragmatism. And this is what we are debating a lot in Europe, and where we are struggling to get this into action. That's my only pitch. Nevertheless, we have to, as Steve Jobs called it in one of his congregation speeches, we have to stay hungry and foolish, right? So competitive to also take what we know, take what we have, paint the picture of the world that anticipates and automates, as I tried to do this. And this is a global competition. And maybe we as companies, we are all global players. We should use this also as benefit and also, of course, anchor back into Europe where we get the right talent and resources. Yeah, but definitely not a reason for becoming complacent.
I would like to make it a bit more concrete even. Gerd, you're totally right. And Lars, that we should not stay complacent, but we have to change. And the point is, I would like, with all due respect, to contradict Gerhard in saying we should not work on the old, boring automotive and industrial stuff. We should go for the new one. If we not even manage to stay ahead in the automotive part, I'm more than gloomy that we will come up with other new things. So we should defend what we already have, but we should not stay in the 19th century, which is the danger. So we were optimized in the 19th century in an industrial hardware, metal bending kind of spirit, and this we have to change. And this is a very painful process for the companies. And I would just look at our own company like Bosch. We are transforming ourselves in an AIoT company, so Internet of Things with AI. And this is really a huge endeavor. We are currently training 20 to 30,000 managers in AI and software basics. Mandatory, everybody has to go through that. And some give up, and perhaps they are not the right managers for the future then. We make everything connected. By 2025, every product from Bosch will be not only connected, but will contain AI, or will be engineered with AI or manufactured with AI. This is a hard goal, a bit dictatorship-like commanded by our CEO, and it was absolutely the right thing to do. And it takes some time, but I think we have learned our lesson. We have seen what Tesla is doing. We are reorganizing. We have brought all automotive software in one entity, centered around vehicle computers. You know Conway's law that the system looks like the org chart of the organization. So you have to change the organization to come into the right spirit, and we are doing all of that. And all the other European companies, at least the ones who stay, let's say, in the competitive game, are doing the very same at the moment. And this is the company internal part. But coming back also to the outside world, the outside has also to be fast. So as you have said, we need fast funding schemes, perhaps a bit less money, but quick. And then look in this kind of MVP agile style, what's coming out, and then increasing funding if it's successful, or stopping it if it was like a dead end. And also, we should not forget about legislation. So the local spectrum thing with 5G was excellent. It helped us coming much closer to this vision of the factory of the future. This only goes if you have this kind of private licenses, local spectra, and so on. And so we have learned that this was a good example, and we have to build on that, really come up with legislation fast. I give you another example where we were slow, like in automated driving. We are now coming up with a legislative framework for automated driving, which is in the US there for years already. And then you cannot expect to have the innovation happening in Europe. We need the framework to be able to put things on the street or in homes, in terms of smart homes, or in the factories.
Jan, if I may ask, so where do you see then the role of the operator? You're not an operator, I know, but you do sell things to operators, and the equipment suppliers. And looking at that from the semiconductor to the equipment supplier to what the operators want, is in this kind of a context, everything got to change now with what Thomas was saying in terms of 5G campus networks, or CBRS band networks, as it's called in the US?
Well, yes and no. I think Lars made a really good point about offers being made now from all regions all over the world. I mean, we are Ericsson is a global company, and we are getting offers to start up test beds and experiments and from everywhere. But Europe is really slow when it comes to that. I think, and of course, I mean, I'm listening to Thomas as well. I mean, Ericsson is also going through a dramatic transformation. I mean, we are, of course, a digital company, maybe more than some companies in the car industry, but still, it's a massive transformation that's going on right now, with retraining personnel and changing the R&D model and so on. But I think the most important thing is, this brings me back to the operator question, is the fact that 5G and with time also 6G will be one of the most important innovation platforms in society. And as I said in my presentation, many governments have understood this. I mean, the Chinese government have pushed really, really hard to roll out 5G in their country because they believe that it will benefit the entire society. It will be a fertile ground for innovation, for new companies, for competitiveness of their industry. Same thing with Korea, and also the US for that matter. So I think a very important factor is to make this innovation platform available to the both the public sector, of course, but I mean to industry and to innovation programs, to small companies, because I think, I mean, some of us are big multinationals, and we can, of course, we have a fair amount of innovation, but it's difficult to move too far outside of your comfort zone, of your core business. For that, there needs to be other players, and these players needs to be exposed to this new world, these new opportunities that 5G and with time 6G will also bring. I think the traditional telecom operator will of course have a role in this, but we will see more hybrid schemes as well with terahertz the use of terahertz or millimeter wave technologies, for instance, a sort of a nationwide license for spectrum may not make sense anymore because, I mean, the reach of that type of radio signal is very short. There may be all sorts of hybrid schemes for making spectrum and radio technology and connectivity as well available. I think there are some players who are not even operators today who are really hungry to get into that. And that's a sort of a competitive situation that I think some of today's operators have to think really seriously about. And also equipment vendors for that matter, because that may turn the tables on how you build networks and how how investments are made and so on. So it's a really complex picture, but I think to me, the bottom line is that we need to make sure that we have cutting edge digital infrastructure available in Europe, because that's really the fertile ground that we need to build our competitive future.
Gerd, if you quickly allow me for a comment on
yeah, absolutely.
And Thomas, I mean, what you observe in Europe a lot is now you see companies as the two described who need to transform. Very often we have boards that are composed out, Thomas, you phrase it right, out of metal benders and welders to stay in that industry. Now, of course, everyone feels the need, we need to change something. And what is happening then is that you get a software responsible person in that is coming out of the Bay Area and was an app developer by background. And there the thing completely derails. Sorry for my bluntness there, but I mean, we want to talk how we improve robotics, how we take the connectivity, and as Björn described it, I mean, in principle, we need to educate a complete society to play with that and to understand what now are the real important tools of the future. That you have experience in app developing does not help you an inch in that entire thing. And this is where suddenly it looks like total helplessness, because you take an assumption, I bring software into the company now, I change it all, and it goes completely belly up. And these type of things will be needed, that we have thought leaders, technical understanders in the right positions who can take the European assets and help transforming the companies in a way like society also transforms. And that is a bit a thing that I'm observing at the moment. 1-2 learning cycles later, maybe we don't have a problem anymore and everyone has understood it. So I hope that this is the way forward. But that's also what you're seeing at the moment, big time. And this is what is fueling this discussion of, is Europe totally behind? Because we have a couple of mistakes that you can observe in the industry.
I would sort of take that and make it even more extreme to sort of provoke a couple more ideas on that. I would say the era of software products that we are currently in, and the hype of the software products that we're currently in, will be not marginalized, but will be dwarfed by the era of robotics that we will move into. And so now what that means, if we can really make 5G, we're using as robotics, tactile internet, to make sure that we can have that for industrial, automotive, agriculture, construction, and whatever kind of industries applicable, learn. And as we do that, we can generate then 6G in some kind of fashion that we can bring this to true consumer robotics. Yes? Not only the little bit vacuum cleaner that we have helping us at home and the little bit of the lawnmower and whatever all, but truly even that we have exoskeletons instead of walkers as we become older and we can jump around like a little kid and whatever all. So a true vision that it will be games as kids, helpers as us when we start becoming older and more mature, and all the way to true helpers, making sure that our life stays nice. Now, if we look at this kind of vision, what I think is, it is about being able to sell, produce haptic products. So it is also about understanding the chain, the logistic chain, and everything of being able to provide these kind of things. So it is not only the development side, it's not only the AI inside and the semiconductors inside, it's also all the way to being able to do maintenance, returns, and all these kind of things. And Europe is great at that. The non-robotized consumer products. But we are super strong in consumer products, not in consumer electronics, but in everything. If you think of consumer products that not yet have electronics, but they will completely be robotized. So where do you see that your company or Europe can grab a hold of this kind of opportunity such that we really get this wake-up call? And I can see that 6G can be the door opener for Europe to truly take a lead in this kind of innovation. Yeah. If we wake up. So where's your comment on that?
So I have to go in here. So we are already woken up, and I told that we are becoming, or we are already in many areas, an AIoT company. And I totally agree with your statement that the area of pure software is over or will diminish in importance with regard to let's say the combination of software, hardware, and intelligence and communication. And then we have this AIoT. And this is what we are already doing. So just look at our product spectrum, and we are full on way. The robotics part will naturally emerge as the next step. And I really have to hint, and let's say being in a global responsibility, we should be fully aware that the pace of innovation, or rather the customer preferences, are vastly different in different regions. Japanese are very playful, and they love gimmicks. They love cars with 150 switches. They have no problem with that. They love it if they don't find switch number 85. We are not so much, and we have tried to bring some products to the European markets, which we are selling like hell in Japan, or with other flavor in the US or in China. The European customer is a bit more conservative, usually, but more stable and more quality oriented. And as global companies, and we are all global companies, we have to leverage also this global view here. And but there's a sequence. Have good products like the mechanical products. This is the metal bending 19th century parts. Check mark over. We are master in that. Connect them and make them. This is 5G. We did that. Check. Now bring in all the sensors and come to this data-driven product development cycle where you learn from the products, where you have this kind of DevOps, this infinite loop everybody knows, and learn from data, make products which you sold more intelligent without changing the hardware. This is what's exactly happening at the moment. So I get a regular update on my, I already get regular software updates in my oven wirelessly. So, and we have built all the small, smart and connected sensors. Next step. And robotics, you see first products like lawnmowers, vacuum cleaners, in industrial self-driving lafettes, things like that. We are already there. And being head of corporate research, much more to come, exactly in that direction which you are hinting.
Yeah, so there, just to add to Thomas's view is, just to give you an example, the self-driving robots that we have seen on the roads in the last 3-4 years, also as test vehicles, whenever they have created a severe accident or fatality, fortunately there have not been many, but whenever it happened, it was an issue on the analog to digital side, conversion side, the sensing. So these devices had poor sensor systems, overlooked a pedestrian, a bicycle driver, overlooked a truck, drove under it, these type of things. In no case the brain was the issue, in no case the arms and legs of the robot had been the issue, but it was the eyes and the ears. So the sensing part overlooked topics. Now, that is, of course, also the most difficult one. So having basically an optimal sensing environment that is better than last the driver, that is, of course, a strong contribution that we as a company try to bring into that. And just one other thing, if I'm looking at a combination, what I mentioned prior of sensing and connectivity, I mean, there's also a question on ethics and how we're going to build these systems. I mean, talking software is basically a technical ingredient, talking robotics is a system discussion. And now in that system discussion, what I need to do is I also need to think of what could be constraints of my technology. Just imagine my Wi-Fi router at home would be a 6G router and would be able to X-ray my entire house and know exactly who is where and why. Do we want to have that? privacy-wise? How do we secure that? What do we do with these surveillance systems? So in other words, we need to open a chapter of ethics in system design, AI ethics, and God knows what. And this is what we are working on at the moment. Sounds a bit strange in the beginning. Why does a company CTO care for AI ethics? The only belief in my claim is, if I don't do it, my mom and my dad will not trust the devices that Thomas wants to sell them, washing machine or lawn mowing robot. And then this entire market is not coming to existence. It's collapsing. So in other words, we need to do this job of demystifying, simplifying, but also putting the right boundaries in place. And that is what we, with our consumer goods experience, should transfer into robotized consumer good experiences.
I couldn't agree more, and this is exactly the reason why we created an AI code of ethics, and I was personally part of the discussion round, and our CEO and CTO, Mr. Bolle, Mr. Denner, they spent, I would say, in total like a week on this issue, personally discussing what is the right thing. And being a global company, being active also in China and other regions, this is not a difficult thing. So how much business you're willing to give up to obey to your own code of ethics. But it's an absolute must. And we also had an IoT principles far before we got the GDPR. And when GDPR came, it was not a problem for Bosch because we did that already, knowing that digital trust is an absolute prerequisite to sell those products, which get connected, which sense almost everything. People have to trust us. And if they don't, no big market will emerge. Again,
okay, so now
takes part here, but this is also important.
Yeah, I support
yes,
that
Caroline.
fully. Yes,
exactly.
I think from the end user point of view, there is this acceptability, which is very important and essential. We agree that Japanese people behave differently, have different expectations, for instance, as you mentioned. Also, trust and security and privacy are very important. And if you look also at I would say the fear of the citizens, those who destroyed some 5G antennas because they are afraid of radiations. We have the same with, I would say, semiconductors. They are afraid of nano particles because they believe nanoelectronics is dangerous. So you have all those, I would say, soft things to address before you can go to a wide market acceptance. And I think this is important not to forget.
Good. Now, if we look at this, if I look at you, Björn, if I look at you, Lars, if I look at you, Thomas, and most of the companies that you represent, Caroline, or let's say a large part of them, you're big corporates. Yes, and we all know that big corporates normally do not live forever. So that's the one big way of big corporates being able to survive, like Bosch, 125 years, is by buying innovation. And by buying innovation, that means you buy startups. Yes, of course you collaborate with research, others, people as well. Don't get me wrong, but I mean, one core part of that is that innovation often happens much faster at small companies that are quick and have not the processes in place which are needed for the trust and whatever all. But so they can sidestep on that and come up with solutions quicker that then you buy and you put into your big machine, and out comes something that we can then really trust and buy. So everybody has their values. I'm not saying that small companies are all good and big companies are all bad, or the other way around. Everybody plays part of that. That's how the whole system works. Now, what we see and what we have been seeing is in semiconductors, in automotive, in many other areas, a monopolization. There's a Google, there's a Facebook, there's a, it's a monopolization. There's a Tesla with a market cap that is so much bigger than everybody else. So as we see this also in the semiconductor industry, yes, Qualcomm tried to merge with NXP, and Broadcom tried to merge with Qualcomm, and not every of these mergers works out and happens, but yes. So how do we make sure that we have enough innovation? Because on the one hand, we have this monopolization. At the other hand, we see less entrants. If I look, for example, Björn, in the telecom equipment market, yes, there's 2 left out of how many? There were 10 suppliers 10 years ago, so out of Europe. So we have a total monopolization of these markets. And what do you think we have to do to make sure, from a semiconductor point of view, that we address this in the right way, so that we're not doomed because suddenly that company is gone, either because of mismanagement or because somebody snatched it away, and Europe is left without everything?
I think that the answer is multitude. I mean, that we create this, and I sort of tend to go back to my comment before about creating this fertile soil for innovation, where new companies can grow up and can develop alternative approaches to that of the big incumbents. I think it's healthy that I mean, the big multinationals get challenged and get competition, and I mean, Ericsson is there's an interesting fun fact about Ericsson. I mean, if you look at the main business of Ericsson today, that came with an acquisition back in 1990. It was there was a company called Radiosystem AB, which was acquired by Ericsson, and the business of that company, that acquisition, that little company, is actually Ericsson's main business today. And I wouldn't be surprised if that in a couple of years, I mean, our main business in Ericsson will be that of an acquisition we made some time ago. So I think this is true for all big companies with longevity. I mean, you typically transform. You're not the same company 20 years later. You are very different. If you are not very different, you are dead. So no, I think we need, in Europe, we need this fertile soil for innovation, and it brings me back to, I mean, to have 6G available everywhere is really a key matter here, because that will create part of that fertile soil for innovation, at least.
And Gerhard, if I can add the NXP story. So when I joined NXP 2008 from Conti, I very honestly, I thought I had made the mistake of my life, because when I joined, they told us that 3 months later we could be bankrupt. So we only had cash for 3 months. 5 years later, we were one of the most profitable semiconductor companies globally, and we could buy not a startup, but Motorola Semiconductors, free scale. And I mean, that transformation, that merge, and bringing the 2 companies together. By the way, neither the American footprint nor the European footprint has suffered in that. We grew together further. But that was the story for that portfolio for the smart connected devices. Because NXP was strong on the interfaces, sense and connect. Freescale was very strong on the microcontroller part. So that was a perfect merge that we needed. And we have hardly switched off any portfolio in that entire exercise. Now, we bought the Wi-Fi business and Bluetooth business of Marvell Semiconductors and so on. I would also not say a startup, but a significant chunk of a multinational. So, of course, these moves are going to happen. Qualcomm was not successful, but that was a haggling between Trump and China. But the rationale also was very clear. We were strong on that smart connected devices side, and we were lacking the cellular chips. Qualcomm had the cellular chips. That would have been also such a portfolio story to grow further and to transform further. And this rationale behind it, of course, that has to fit. Location is in all of these considerations usually not the key factor. So does it have to be in Europe or in US or in Asia? Europe and other locations, of course, they have to be careful that they don't kick out the multinationals. So is this a ground where you can protect your IP? Is this an area where it is attractive to have an R&D center? And is it an environment, and that was my point earlier, where it is attractive to anchor new activities? I'm responsible for 60 R&D centers globally. And now the key question, just to give you an example, is on 6G incubator. Hamburg, Nijmegen, Toulouse, Austin, Phoenix, or do we go Asia? I mean, this is where also Hamburg, Germany, Europe, Toulouse, where we are competing inside this setup. And there, of course, the key question is, can Europe give me a little bit of a stimulus to anchor it in Europe? Or is the US faster with a small stimulus? And there I have the first 10 developers, usually the activity stays. So it's not huge money. This was my pitch earlier to make it a bit tangible, what I was talking about here.
So Lars, we should talk, because as you have heard, the 5G 6G Innovation Center for Vodafone has just been decided to be set up in Dresden. And obviously I did play a little bit of a role in convincing. So I think we have to talk.
to that discussion, but yeah, we are sitting in the same fishbowl, obviously. Yeah.
Yes, absolutely. So, but to close up on this, I think I've brought all the questions that came from the audience. Thank you also for the audience for active participation. To round this up, I see 5G is sort of, we learn, as Thomas said, we have to learn with the old tankers like automotive and whatever, and industrial, yes. And take what we learn to bring this to 6G to consumers. And it's about putting AI, robotics, communication, sensing, everything together to make this thing happen. And then from the products, learn how to drive, as Björn nicely put it, into the smart semiconductors, take these system expertise into the right semiconductors and drive Europeans' semiconductor technology roadmap that way. So I want to thank you all. This was a lively discussion. I had a lot of fun. I hope you also had a lot of fun in this, and we'll talk and continue this kind of discussion in the future. Thank you very much for your participation.
Thank you so much.